Okay, this video is going to be about the properties of logarithms, but they're closely related to their inverses, properties of exponents. So let's review a few rules. The product rule for exponent, when you multiply powers of the same base, remember this is what we're talking about. These bases are the same. When you multiply powers of the same base, you add the exponents. And that should make sense visually. X squared times x cubed, you end up with 5 of those x's, x to the 5th. All right? Now, when you multiply powers, you add. When you divide powers, you subtract. Numerator exponent, subtract denominator exponent. That also should make sense. X to the 5th divide x squared. Well, this x divide x, this x divide x, and that leaves x cubed. All right, so that's the product rule, quotient rule, and then the power rule. When you raise a power to a power, you multiply. Oops. And that should make sense. X squared cubed means x squared times x squared times x squared. Remember a minute ago when you multiply powers, you add? Well, when we multiply x squared times x squared times x squared, we add 2 plus 2 plus 2, which is 6. So visually, that makes sense. When you raise a power to a power, you multiply. 2 times 3 is 6. Or rewrite it as repeated multiplication. Okay, so now I'm going to tie this into properties of logarithms. And I'm going to ignore, let's see. I'm going to ignore some of this stuff first. So, when you remember what we did here, when you multiplied bases, the exponents expanded to addition. Here, when you multiply the argument, when inside the argument, so almost looks like two different arguments here being multiplied, you expand that to addition. So log, and inside there's two arguments, it becomes two separate argument. See, log x plus log y. So when you have a plus sign between two logs, oh, by the way, the base numbers have to be the same. That means it can expand, it can condense back to one log where you multiply them. So when you multiply inside, arguments are being multiplied, it can expand to the addition of two individual logs. And if you have two logs being added and their base is the same, you can condense it to log of that same. They have to have the same base, or the laws don't apply. And then you multiply the two arguments. All right. So then the only thing that we have here, see how we have these powers? Remember what we did here. When you raise a power to a power, it meant multiplication. That's what's going to happen here. So we're going to expand these. Well, this 5 is on the outside of all of it. So this is log base x, it's being raised to a power, plus log base y, and then all of that was raised to a power. Remember what we do, when you raise a power to a power, you multiply. So for logs, you bring it down in front. It just so happens that this 5 is on the outside of all of that, and then in here it's 4 times log x plus log y. So now we can do the distributive. So 5 times 4, that becomes 20 log x plus 5 log y. See what we did here? So those two are expanded, and the x, that 2 would go back up there, and that 4 would go back up there. So because this has been expanded, when we condense, we have two arguments being multiplied. And remember, when something's being multiplied, it originally started off being an exponent. So we have x squared times y to the 4th. And that's just working backwards. Okay, I'm going to review a couple more exponential rules. When you have any non-zero number, it could be e, or any other base, to the 0 power, it always equals 1. And when you have a negative exponent, then it can be rewritten as 1 over 1. All right, so the reason I'm going to do that is because that ties into two different, and I'm going to do both ln of e and log base 10, but it could, of the log logs, it could be any base. So log base 10 of 1, just like ln of e, ln base e of 1, those answers will always be 0. Doesn't matter what the base. This could be base 2. When you put a 1 in there, you're going to get 0. And then the other thing is, when you take the log that has the argument is the same number as the base, so those are facts that are important to know, because we're going to do 2 more problems. 28 looks more complicated than it is, or yeah, 28 looks more complicated, but I know that 729 is the same as 9 cubed. And then this 3 is going to come down in front. Well, look at what we have. We know that log base 7 of 9 is 1.1, and when you multiply that, you get 3.3. This should be in parentheses, just like that. All right, that's it for this one.